Now let's talk about the second key idea, which is the confidence interval. The confidence interval is going to be equal to the estimate plus margin of error. Okay. Now, why? We have already talked. The sample is never going to be exactly same as the population attribute, right? Whatever the attribute you're interested, right? For example, if you're calculating a statistic, right, that's not going to be perfectly equal to the parameter that you're calculating for the overall population. And so this idea is basically encapsulated and captured by the confidence interval, where the estimate which you have done, right, this can have a margin of error. So you also do plus minus margin of error on top of the estimate that you have calculated from the sample. Okay. And the lower bound of this confidence interval is estimate minus margin of error, and the upper bound of this confidence interval is estimate plus margin error. Okay. So here is an example that survey result of a sample of a population, and you saw 55% of them support a policy decision. And if the margin of error was reported to be plus minus 3% in that server, right, then you can calculate the lower bound to be 55 minus 3, which is 52 right here. And the upper bound is 55 plus 3, so 58 here, right? So this is the estimate value, this is the lower bound, and this is the upper bound of the overall confidence interval. A confidence interval gives a range. So you can see from here to here a range of possible population value. Okay. So essentially what you're getting from this survey and the results that you're collecting from the sample for the population is you're basically getting this range. Okay. 52 to 58% will support the overall population. It will never be a single value. Okay. Okay. Now, when we are talking about margin of error, how much the sample estimate may differ from the true population because of the sampling variability, right? Remember, we talked about that when we are randomly choosing samples from the overall population, we can choose, since we are choosing 200 out of maybe 18,000, there are many ways we can create that sample, even if we are doing a random, right? And because of that, we will face the issue of the sample variability, right? So that's where the margin of error basically that is encapsulating. It basically estimates how a sample estimate might be different. It captures, so it's a measure of a capture of how sample estimate may differ from the true population value because of the sampling variability. So if 48% support a candidate plus minus 3 errors of margin, then the likely range is 45% to 51%. Larger the sample size in the overall, if your sample size is bigger and nearer to the close total of size of the population that you have, then you will have smaller margin of error because you're using more number of people, you're collecting data or whatever you're interested in on larger number of people. So it's going to be closer and closer to the true population mean. It never will be exactly like that, but it will be closer to the true population. So that's one thing, concept that you need to keep in mind, that larger sample size leads to smaller margin of error. Larger margin of error, right? Higher confidence interval that you have, right? Leads to larger margin of error. More variability in the data, you will need to have larger margin of error. So margin of error basically describes uncertainty around an estimate, and that's what it is capturing. Okay. Now, how do we compare intervals for a same specific thing? Okay. So let's say we have these two candidates, like, and we did a survey and we found that candidate A had 52% estimate for whatever we are interested in with a margin error of 4+4. Then candidate, you can see the range. Okay. The interval will be 48 to 56%. And if you look into the candidate B with this data, then the interval will be between 46 to 54%. So if you plot them on top of each other, you can see that this is the region where there is an overlap. Okay. Because there is an overlap in the range that you have, the pole does not show a clear letter because there is a issue. that is here. Now, here is another example. Program A and program B with certain sample mean and the margin of errors. So this range will be from 76 to 80%. For program B, given by 70% plus 2% of margin error, this will be 68 to 72. Now, if you plot them, right, you see the interval that you have in this left-hand side for program B is on the left hand side, and it does not overlap with the interval that we have for program A. Okay, now we have a non-overlapping intervals, right? So in this, it basically supports a clearer difference, and it tells that program B, probably if higher is better, then program B is clearly the leader or is better compared to program A, right? So use intervals to judge whether differences are clearly supported. If there is overlap, there is no clear winner in the two choices that you might have. But if there is no overlap, then definitely there is one clearer winner among the two candidates or three candidates you can have. Okay. So what are the things that affects margin of error? Sample size. Bigger sample size gives smaller margin of errors. Confidence level. Higher confidence gives a wider interval. And variability. More spread in data gives a larger margin of error. Okay, so here is an example of sample size. If you have 400 and you have a 1600, then in the 400 you may have more variability and the interval is going to be larger. But if your sample size is bigger, let's say 4 times bigger than the first case we see here, in this case, right, it is going to be similar. Mean-wise, it will be similar, but the margin of error is going to be lower in this case. Okay, so larger sample size, you have a smaller margin of error and you have more precision in your estimate, whatever you're trying to estimate. Okay, so margin of error changes when sample size, confidence level, or variability changes. Okay, so these are like some of the main concepts that I wanted to discuss. And then based upon practicing some of the other problems, we will try to learn various different aspects about this overall topic. So again, in order to solve this problem, what is margin of error? Estimate plus minus margin of error leads to the interval value. So if you take the high value, which is 7.98, right? And from this, if you subtract the low value, which is 72.4, that's the overall interval, and divided by 2, that's the delta of the interval, divided by 2 is the margin of error, right? So this is what will give you the D as the right choice. Okay, so now let's look at a cleaner version of this solution. The next slide. The margin of error is half the width of the confidence interval, right? So that's the key idea. If the confidence interval is this, now how your estimate will be here. This is the plus portion and this is the negative portion, right? So half of this overall interval is essentially the margin of error or MOE, right? So that's the key confidence that we are using. So we will find the interval width by taking the maximum value, subtracting that by the smaller value or lower value of the interval, which is 7.4, divide that by 2, which is 3.7. So the margin of error is going to be this. Makes sense? And if you want to find out the center, then center is basically this plus this divided by 2. So again, this question was focused on margin of error, but if they needed to find out what is the estimate and the margin of error together, then you basically sum that, divide by 2, and you will get this. This is going to be the central value. Okay. So if you want to estimate this central value, you can take lower and upper and divide that by 2. That will give you the center. Subtract upper minus lower and divide that by 2. That will give you the margin of error. And you can combine that result to write something like this.